Dear participants, it gives me honor to present our study titled Development of an Artificial Intelligence Supported Mobile Learning Application. In this presentation, I will briefly discuss the introduction, methods, mobile application, development process, user interface and navigation design, statement management and security, data flow and API integration, modules and media content, and AI supported digital assistant. And then I will finish my presentation. Transition from teacher education to professional teaching environment is not always smooth for pre-service teachers especially. Many of them face difficulties in adapting to realities of school life, professional responsibilities, and institutional expectations. In the literature, this challenging transition is explained through the concept of reality shock again. And reality shock, I will make a short definition of reality shock. Reality shock may negatively influence pre-service teachers' professional confidence, motivation, and sense of preparedness. For this reason, it's important to provide support systems that are accessible, flexible, and responsive to learners' needs. At the same time, mobile technologies have become an important part of educational life. Mobile learning applications allow learners to access educational content regardless of time and place. In addition, when mobile platforms are supported by artificial intelligence, they can go beyond simple content delivery and become more interactive, adaptive, and supportive learning environments. Based on these needs, our study focused on development of a mobile learning application designed to support a web-based instructional environment created for pre-service teachers. More specifically, the study presents how an existing web-based educational system was extended into a mobile environment and how this mobile application was structured technically and pedagogically in the same time. When we look at research model, we can say that this study was designed as a design and development oriented system development research. The main aim of the study is not to measure the effectiveness of the mobile application, but to explain the development process, design decisions, technical architecture, and implementation structure in a specific way also. In this context, the study focuses on how a web-based instructional environment developed for pre-service teacher was adapted into a mobile learning application. So the study is product and process oriented. The paper mainly presents the design logic of a mobile application, its technical components, interface structure, and data management systems, and artificial intelligence integration. We will talk about that. Now, I would like to explain the mobile application development process. The mobile component of the project was developed using React Native, which is a cross-platform framework that allow developers to create Android or iOS applications from a single code base. This framework was preferred because of its performance, sustainability, and also maintainability. The application was developed using React Native SLI, and the development environment included Android Studio and IntelliJ IDEA. JavaScript was used as the programming language. Because of this, its modular structure and wide library support. From an architectural perspective, the mobile application was designed with a component-based structure. This approach helped separate interface elements from business logic and made the application more manageable, reusable, and scalable. And I want to add this that The mobile application was not developed as an independent system. Instead, it was designed as a complementary component of the existing web-based instructional platform. In the other words, uh, it extends the learning experience from the web environment into a more flexible and portable mobile form. Another important aspect of the project is the user interface and navigation design. In educational mobile application, interface simplicity and ease of navigation are very important because users should be able to access learning materials quickly and intuitively. To achieve this, the application used React Navigation F7. The navigation structure was built on two main components. The first one is bottom-top navigation, which provides quick access to the most frequently used sections of the application, such as home, modules, chat, and profile. And the second one is the stack navigation, which organizes the transition between content pages in a more detailed and hierarchical way. This combination helped create an interface that is both user-friendly and functionally organized. The goal was to ensure that users could move through the application easily, access learning materials without confusion, and maintain continuity in their learning process. The next important issue is state management and security. In mobile application, especially those involving user accounts and learning data, state management is critical for maintaining a stable and consistent user experience. It ensures that user sessions information, progress data, and server response are handled in a controlled and predictable way. In this project, Redux Toolkit was used for centralized state management, user authentication, session information, API responses, and real-time application states were all managed through this structure. And authentication processes were handled asynchronously, and user login operations were organized through a centralized structure. The access token received from the backend service was stored securely using async storage. Maybe you know about that. It's an encrypted manner. This allowed the user session to continue even when the application was closed and reopened. Security was considered essential not only for protecting personal data but also for preventing unauthorized access and ensuring system integrity. Communication between the mobile application and the server was handled through the Axios library, which is a promise-based HTTP client. And API requests such as GET and POST were centralized managed, and request settings such as headers and timeout durations were standardized. One of the strongest points here is this architecture is the way authorization data is handled. User data stored in the Redux store are automatically added to request headers through Axios interceptors. This ensures that all data exchanges takes place within a secure authorization framework. So data flow in the application was designed to be both efficient and secure. This slide also tells about request management and data integrity in the same time. Our application also includes a structured module and media content system. The instructional materials were adapted for mobile use in a way that would preserve both accessibility and quality. Different technologies were integrated according to the content type in that side of the research. And here, for video-based learning materials, the React Native Video Library was used. This allowed users to watch module videos, switch to full screen mode, and control playback settings. And for documents also, especially PDF-based course notes, React Native File Weaver and React Native FS were integrated. These libraries enables users to open and manage educational files directly within the mobile environment. For visual support and interface enhancement, technologies such as Lottie React Native and React Native linear gradient were used. These elements contributed to a more modern and engaging user experience. The artificial intelligence model that already existed on the web platform transferred to the mobile application also. Technically, user messages are sent asynchronously to the server through RESTful API calls, again using Axios. The responses generated by the AI system are then reflected instantly in the mobile chat screen. When it comes to talking about conclusion, we can say that this study presents the design and development process of an artificial intelligence supported mobile learning application created to support a web-based instructional environment for pre-service teachers. The application was developed as a complementary mobile component of the web platform and designed with attention to technical architecture, user interface, navigation, state management, security, data flow, and etc. Overall, the study shows that mobile technologies can play an important role in improving the accessibility and sustainability of educational environments. It also demonstrates that pedagogical needs can be successfully integrated with technical design decisions especially. At this stage, the study doesn't present effectiveness results, but it provides a strong technical and structural foundation for the future research that will test the impact of the application on pre-service teacher, a professional adaptation process. And then we can talk more about this issue again. Dear participants, now we reach the end of the presentation and thanks for listening us.